Hello everyone. This video would focus on isosceles triangle theorem, and this is the second part. Before we go over these examples we have right here, let's have a review on isosceles triangle theorem. We remember that an isosceles triangle is a triangle with two equal sides. So looking at this triangle that we have right here, side AB and side BC have been marked with this tick mark right here. This tick mark tells us that these two sides are equal or they are congruent. So then we can go ahead and say that this triangle that we have here is an example of an isosceles triangle. Now, what is an isosceles triangle theorem? This theorem states that if two sides of a triangle are congruent, then the angles opposite to these sides are also congruent. So I'm just going to go ahead and write that down here. So looking at this triangle, we have side AB and side BC. Again, these two sides are congruent. The tick marks tells us that. We can go ahead and say that the angle across from AB, which is angle C, and the angle across from BC, which is angle A, both of these angles are congruent. That means they are equal. So that we can go ahead and say that if AB is congruent to BC. So if these two sides are congruent, then we can go ahead and say that angle AB, opposite to AB, is angle C. So angle C is congruent to angle A. Now let's have the converse of this theorem. The converse of the isosceles triangle theorem states that if two angles of a triangle are congruent, then the sides opposite to these angles are also congruent. So I'm just going to go ahead and write that down here. Okay, so looking at this triangle right here, if our angle A is congruent to that of angle C, so if both of these angles are congruent, then we can go ahead and say that our BC, that's the side across from A, and AB, that's the side across from C, would also be congruent. So we're just doing it the other way around so that we can go ahead and write this in a statement. If that's going to be angle A is congruent to angle C, then we have opposite to angle A is BC. So line segment BC is congruent to the one opposite to angle C is side AB. So this is the isosceles triangle theorem. So let's take this first example. So we're supposed to solve for x. Now notice that in this example or in this picture, this is an isosceles triangle. The reason for that is these two angles are equal. This tells us that these two sides that we have here are also congruent. Again, that is the isosceles triangle theorem. So that we can go ahead and say that this 3x plus 16 and this negative x plus 8 would be equal each other. So that we can go ahead and write that down here. So that would be 3x plus 16 is equal to negative x plus 8. Because then again, both of them are congruent to each other by isosceles triangle theorem. So that we can go ahead and solve for x. So we add x to both sides plus x here so that we are able to cross this x and x out. We are left with 4x plus 16 equals 8. So then we are going to subtract 16 from both sides because again, our target is to solve for x. So minus 16 and minus 16. So then we go ahead and cross out the 16. So we're left with 4x equals 8 minus 16 is negative 8. So that we go ahead and divide both sides by 4. So divide this by 4 and divide this by 4. So we can cross the 4 out. Our value for x then is equal to negative 2. So this is our value for x. That's negative 2 right there. We can check if we got it right by plugging in values to see if both of them are equal each other. So that would be 3 times negative 2 is negative 6 plus 16 is 10. So this length here is 10. We can go ahead and label that down here. We also plug in the -2 to the other one here. So negative of -2 is a positive 2. Plus 8 is also 10. If you notice, both sides are equal to 10. Again, that is based on the isosceles triangle theorem. Now let's move on to the second example. This example is again an example of an isosceles triangle because we have two sides that are equal. This tells us that these two angles are also equal, so that we can go ahead and set up the equation that's angle A is actually equal to angle B. Both of these angles or both of these base angles are congruent to each other, so that we can go ahead and plug the values in. So we have that's going to be 2x plus 12, that is angle A right there, and then our angle B is 5x minus 18, so that we go ahead and solve for x. I'm just going to show the work down here. Okay, after doing the math, our x value is 10, so we can go ahead and plug that up here. So that is our x is equal to 10, and we're supposed to determine the measure of angle A. So angle A is 2x plus 12. So what are we going to do now is we plug the value of x into the equation. So I'll set up the equation up here. So angle A is equal to, that's 2x plus 12, so 2x plus 12. So what I would do is, since we already know the x, so I plug the x into the 10 into the x right there. So this would come out 2 parentheses plus 12. And then again, our x was 10, so I plug it in there. 2 times 10 is 20 plus 12 is 32. So this angle that we have here, angle A, is 32 degrees. So this corner right here is 32. Now, since we say that angle B is also equal to angle A, we're supposed to get angle B as 32. But then I'm just going to show the work for angle B right here. We plug in the x, which is 10, into the equation. I'll show the work down here. Okay, you notice that the two angles A and B are congruent to each other because, again, the side across from them are also congruent. Again, that is the isosceles triangle theorem. Now, we are supposed to determine the measure of angle C. Now, please remember that the sum of all the measures inside the triangle should always be 180 degrees, so that we can go ahead and set up the equation. We add all of these three angles and equal them to 180. So that is angle A plus angle B plus angle C should always be equal to 180 degrees. So our angle A, we've solved it. That is 32 plus our angle B is 32 plus angle C is equal to 180. So that we go ahead and combine like terms, 32 plus 32, so this two becomes 64. So that is 64 plus angle C equals 180. We want to solve for angle C, so minus 64 and minus 64. So we can cross the 64 out. We are left with angle C is equal to 180 minus 64 is 116 degrees. So this is the measure of angle C. So I'm just going to fill that up here. So that's 116 degrees. Now let's move on to the next example. If you notice, we have two isosceles triangles combined together in this picture. So that's the first isosceles triangle, the one on the left side. And if we cover the other triangle right here on the left, that's another isosceles triangle right there. In order that we're not overwhelmed with all of the values that we see in a triangle that are combined together, we cover one triangle and we actually have to do it one after the other. So let's cover the one on the right side. So we're supposed to solve for x. Now, please notice that these two sides are congruent. This tells us that the angles across from them would also be congruent. This tells us that even though there's no value for this, that is actually equal to a, so that we can go ahead and write this as 9x minus 20. Again, that is based on the isosceles triangle theorem. Base angles would be congruent or equal to each other if the two sides across from them would also be equal. So that from here, we can go ahead and solve for x. We remember that the sum of all the measures inside a triangle should always be 180 degrees. So I can go ahead and show the work down here. Okay, after doing all the math, our x is 10. So what I did was I added angle A, because remember, the sum of all the measures of the angles inside a triangle should always be 180 degrees. So I added the measures of angle A, angle B, plus angle D, this corner right here. They're all equal to 180. So I just plugged it in, 9x minus 20, 9x minus 20, and we have a 40, and that is equal to 180. And we did all the math, and that is equal to 10. So that we can go ahead and fill this in. Our x here is 10. We are asked to determine the measure of angle B. So angle B originally was missing right here, but we again remember that this is an isosceles triangle. So both of these base angles would be equal each other, so that we can go ahead and determine the measures for angle B. So we just have to plug the values in. So I'm just going to show the work on the side right here. So that would be angle B is equal to, that's going to be 9x minus 20. So then that is 9 times minus 20. Again, our x here was 10. So I put in the 10 right there. So 9 times 10 is 90. Minus 20 would be 70. So the measure for angle B is 70 degrees. So we can go ahead and fill that in here. So this is 70 degrees. This tells us that our angle A is also 70 degrees. We also are asked to determine DBA. So that's DBA. That's still the same thing. That's angle A. The value for that again is 70. Please remember that both angle A and angle B here are both 70. Because then again, remember these, if we cover the other triangles, so we're not overwhelmed by the other values right there. These two are equal each other since the two sides are equal. So that we can go ahead and solve for the next one, which is DBC. So angle DBC is this corner right here. That's DBC. So we need to determine what is this angle. Since we say that this corner right here is 70 degrees, we can go ahead and say that this is linear pair, which tells us that their sum should be equal to 180 degrees. So this tells us that our angle DBC is actually 110 degrees. Because again, the reason for that is both the 70 degrees and the 110 degrees here make up 180 degrees since they are linear pairs. So we can go ahead and say that our DBC is 110 degrees. Now let's determine the other measures here. Angle BDC. So that is BDC. So this corner right here. So we can determine this BDC, and we're not overwhelmed by all of these values here. We can go ahead and cover the other triangle right here so that we can go ahead and just focus on BDC. That's the one that we're looking for. So that we go ahead and say that these two angles here are equal each other because these two sides are equal. So the angle across from them would be congruent. So this one is also going to be 6y plus 5. So that we go ahead and determine the value for y, and once we have the y, we plug it in. Now we have three angles here in a triangle. That's 110. This angle is 6y plus 5, and then this is 6y plus 5. So we remember that in a triangle, we can go ahead and add all the angles together, and that should equal to 180 degrees. So that in this triangle, we can go ahead and say that angle B, that's the first angle right there, plus angle D, this angle right here, plus that's gonna be angle C, this corner right here. This should all be equal to 180 degrees. So that we go ahead and plug the values in and solve for y. So the value of y is 5. So again, what I did here was I added all these 3 angles here. Again, I had to cover the other triangle so we're not overwhelmed by all the other values that are around it. So we have 110. That's gonna be angle B plus angle D, which is 6y plus 5, plus angle C, which is another 6y plus 5. Again, the 3 angles in this triangle should always equal to 180. And I did the math. It came out to be y is equal to 5. But we are supposed to solve for angle BDC. So this tells us that we can actually solve for BDC by plugging in the value of 5 into the y here. So I'm just going to show the work up here. So the value for BDC, angle BDC, this corner right here, is 35 degrees. Now, we are supposed to determine the measure of angle C. Remember, these two are equal each other. You can plug in the 5 in here. 6 times 5 is 30 plus 5 is still 35. Because again, these two are equal each other. So this one right here is also 35. Now, please notice that if we add 35 plus 35 is 70, plus 110 would be 180, which is the sum of all the angles inside a triangle based on the triangle sum theorem. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!